Good morning, everyone. I hope you're all well. We're just going to give a minute for people to join. But I just want to quickly to say hello. Hello from Ireland and from Trinity College Dublin. It's great. Thank you so much for joining us today. And it's delighted to see so many registrations from many countries, the likes of, we're seeing people joining from India, from US, from China, Turkey, UAE, Malaysia, and of course from Ireland. So you're all very welcome today. So today we're here to discuss how Trinity is delivering and transforming STEM education. Melanie is my name. I'm one of the student recruitment and admissions officer at the E3 office and faculty of STEM. What we're going to do today is we're going to have a quick welcome by the chair, Dr. Kevin Kelly. Dr. Kelly is an associate professor in the Department of Mechanical, Manufacturing and Biomedical Engineering Department, School of Engineering. He's also the director for undergraduate teaching and learning in the School of Engineering. So Dr. Kelly is going to very briefly introduce the E3 initiative at Trinity, and then he's going to introduce all the panelists joining us today. Dr. Kelly is going to moderate the panel discussion, followed by a live Q&A. And then towards the end, we're going to have a very quick closing remark from my colleague, Michael Enru. He's going to take you through the list of programs that are currently being offered under the E3 remit and also available scholarship opportunities if you're interested in applying. And most importantly, on how to get in touch with us if you have further questions, after today's session. Today's session is expected to be an hour long. And the session is recorded and the recording will be shared with you afterwards. So without further overdue, I would like to hand you over to Kevin, who is going to open proceedings. Over to you, Kevin. Thank you.
Thank you, Melanie. Perhaps you could put the slides on slideshow format first there, and reiterate what Melanie said to welcome you all to this presentation. So what you're looking at on the slide there is a picture of the campus. I guess it's one of the things we're known for is our very beautiful and historic campus, which goes back over 430 years at this point. In fact, exactly 430 years this year, having been founded in 1592. So what you're seeing is probably about one half of the campus, and where the camera is positioned is pretty much where the new E3 Learning Foundry is going to take place. And E3 I'll talk about on the next slide, but it's really prompted by a sense of the world changing and what we need to do as new graduates and as educators to ensure that those changes are recognizing that we are active, I suppose, in trying to mitigate some of the negative effects that humanity is having on the environment, and also to bring positive solutions. So E3 stands for Engineering, Environment and Emerging Technologies, and it's a short title which tries to encapsulate a very simple in one respect theme, but also a very challenging theme. And that theme is that it's not enough in the world of today, and especially the world of tomorrow, to work only in narrow disciplinary teams. That is, engineers cannot solve the problems of the future if they only talk to engineers, and scientists can't address or understand the challenges of the future if they only talk to people in those narrow silos of science. And the same with our other major school or faculty that's involved in E3, which is computer science, as represented by emerging technologies, and a recognition that all of us need each other's expertise, and we need to bring those together to solve the problems of tomorrow, and not to really think in isolation, but to think collectively, and together we are stronger. So that's the challenge we face in the world, and that has a couple of components. So as a university, we're responsible for knowledge and we do several different things with knowledge. So one is that we discover and curate knowledge. That is, our role is to do research and to find and advance new technologies. So we are the ultimate creators, or one of the ultimate creators of new science and technology. We also, we manage and collate and we share that. So we share that with each other, but we also share it with you, the next generation of prospective students, engineers, scientists, and technologists. So our job is to manage both of those tasks. And in E3, we will work together in a research sense, but we also work together in a teaching sense. So we're really reimagining the future of undergraduate education in these areas. Now, that's not to say we are dispensing with engineering, or we're dispensing with computer science, or we're dispensing with natural science. We're very much not doing that. We will continue to produce scientists and engineers and technologists, but we will be doing that in a fresh way, I think, where all of the students in those programs have exposure and interaction with experts from across those disciplines. So they're equipped and we are equipping them, and they're helping us indeed to address these really challenging problems that the world faces. So as you see on the slide there, our ambition is to create a new kind of graduate that's equipped to lead in a technology enhanced future. So we have a vision then to achieve that, which has an integration which is quite innovative, we think, between our teaching, our research, and a lot of really interesting and stimulating, rewarding project work for our students. We recognized that to do this, our existing facilities wouldn't be ideal, as indeed existing facilities in most universities are not ideal, because they're typically created around the concept of individual disciplines, like, for example, botany or mechanical engineering or networks or computer programming, or whatever the individual disciplines are. They've often, typically in most universities, been in their own buildings, and what we want to do is to create a building solely for teaching and learning. So really putting the emphasis on the student and the student experience, and one that facilitates students to work together in new ways. So lots of spaces for collaboration and communication and for project work. And this new building is the Martin Naughton E3 Learning Foundry, and this is scheduled to open in January 2024, so about 13 months from now. So it's currently in construction. You'll see the cranes if you come to visit Trinity, and it's positioned more or less where the camera on the first slide would have been. So part of creating that new environment is we're creating some new programs. So we'll probably talk a little bit about those later. We have some new options, such as computer science and geography program, which is a new combination of study between natural science and computer science. And we have the environmental science and engineering program, and that's in addition to all of our previously existing programs, which are and will continue to evolve under the E3 framework. So what you're looking at here is a mock-up, an architectural sketch of part of the new building. So in fact, what you would have seen on the previous slide was looking in the window that you see on the left-hand side of the current picture. So this is part of the project working area, and on those white shelves or in those white cabinets are racks of 3D printers. So we've already tried and tested some of these initiatives at a local level, and as the building is completed in the next 13 months, then we'll be replicating and expanding those into the new building. So we go to the next slide, Melanie. We have the next slide there, please, Mel. There we go. So these are a list of the undergraduate programs in the School of Computer Science and Statistics. We have the Integrated Computer Science program, integrated referring to the fact that it's an integration between a bachelor and a master's program. So that is, when you come into the university, you have the option to do 5 years of continuous study leading to a master's degree in computer science, the MCS, with an option also to leave after 4 years with a bachelor degree. Then we have a number of what are called joint honors degrees. That is where you do computer science in combination with another subject, and those options are business, economics, linguistics, and geography. There's a course called Management Science and Information System Studies, which might be best understood, I suppose, by many people as a kind of a data science program. It's a very, very useful and interesting program. And then there's another program, which is a three-way combination between computer science, linguistics, and a language. Within the School of Engineering, we have three programs. We have the Integrated Engineering program, so a similar structure to the Integrated Computer Science. It's a 5-year program leading to a master's degree with the option to leave early with a bachelor's. And in that program, you have 2 years common study where you study general engineering topics with little bits of the 6 programs that are listed there, with the option then at 3rd year to choose the area in which you would like to specialize. So the options there are biomedical engineering, civil structural and environmental engineering, computer engineering, electronic engineering, electronic and computer engineering, hybrid, and mechanical and manufacturing engineering. We then have the engineering with management program, which is also leads to a 5-year master's program, and that is quite closely aligned with the mechanical and manufacturing program with more management and design content. Our newest program then is the Environmental Science and Engineering program. And again, this is a 5-year program leading to a master's with a 4-year option. And in this program, the focus from the early days is on the environment. It's a small class like the engineering with management, about 30 people, with the option to specialize in a more scientific way and become an environmental scientist, or to specialize in a more applied way and become an environmental engineer. So some strong overlap with our environmental engineering areas within the general engineering program, but more specialized. And in the School of Natural Sciences, we have a number of programs. The Environmental Science and Engineering is a collaboration there with Natural Science, I should say. We have a general science program, which has a biological and biomedical science entry route, and also has a geography and geoscience entry route. So if you come in via the geography and geoscience entry route, you're very much part of the E3 family straight away. And if you come in through the biological and biomedical sciences route, you have ways into the E3 family, which would be the botany, environmental science, and zoology routes, or indeed into more of the biomedical sciences area in things like biochemistry, genetics, immunology, etc. So there are the options available as an undergraduate student potentially coming to study in Trinity. I'd like to introduce my fellow panelists here. So I'm going to go in the order in which they appear on my screen, but that doesn't imply stature or importance or anything beyond that. So Juan Diego, first of all, is waving there. Juan Diego is in the School of Natural Science in geology. And then we have Glenn Strong, and Glenn is in the School of Computer Science. We have myself representing the School of Engineering. We have Daniele Novara, who's a graduate from the School of Engineering in civil structural and environmental engineering, and is now the CEO of a company, a spin-out company from Trinity, which we'll hear more about later. We have 2 students. So we've Hazel Hilbert, who's a 2nd-year student in computer science and geography, and we have Shirish Senthil, and Shirish is a 4th-year mechanical engineering student. And Melanie, you've already met, and then we have Michael, who will take over at the end, Michael Enaru, who will take over at the end to talk to us about the specifics about the recruitment and the admission process. So what we're going to do in this session is I will pitch a number of topics to some of our panelists to share their wisdom with you all. And during this, if you have any specific questions, please feel free to use the chat. There's a little chat icon at the bottom of your screen, so you can put questions in there, and they will be brought to my attention if there's anything pressing. Otherwise, we'll just hear from the panelists, and then we do have 10 minutes towards the end of today's session, where we will specifically address those questions, but feel free to type questions and to ask on the way through. Okay, so Glenn, I might start with you. Computer science, like most of technology, the pace of change only ever seems to get faster. And I don't know if that's a second derivative or a third derivative I've just used, but either way, the pace does increase. And how do you feel we as educators can adapt to trying to train the next generation when technology is changing so fast?
Yeah, it's a real problem, isn't it? I mean, you enter your university and 4 years later, who knows what the technologies that were popular or hot when you entered are going to be looking like in the marketplace, right? So for us, I think the key things, the two key things are to teach the fundamentals, the things that are still going to be true 10, 20, 30 years after you begin your education. Make sure you've got that solid foundation. And the other is to teach you as a student or as a participant in our courses to really be able to learn, to think and question, develop those kind of critical thinking and analytical skills that will stand to you throughout your career. I mean, technologies change and fall in and out of fashion, and they, you have to learn these things through some technology. So of course we teach the technologies that are current in the marketplace. We teach the technologies that are cutting edge, but we don't teach them solely from the point of view of, this is what you need. Here you go. You've learned your thing. Get out there and stop learning. Very much more from the point of view of, here are the principles on which these are built. Here are the things that will remain true. And when you leave here, you're going to continue learning. You're going to continue developing. You're going to continue growing and contributing, right? The people who graduate from our degrees are the people who make the next generation of tools, and they need to be able to understand where they're coming from and what they're doing. So what we do a lot of the time, I mean, what I do when I'm teaching these things is sometimes I'll point people towards a selection of the best things for them to use and encourage them to do a little bit of analysis on what they should pick up, and then start learning how to apply some industry standard tool. Go and learn it for yourself, and we'll see how it's applied and what problem it's solving and why it was created. So it's all about learning those important kind of foundations and learning to think and assess and critically build your knowledge of what you're supposed to be using, right? Learn to learn, as they say. My colleague used to say, you don't judge your degree by, the job you get when you leave it. You judge it by the last job you had. The degree should still be working for you 20 years after you leave. We need to teach you that. That's how you deal with the pace of change, I think.
Great, thank you, Glenn. Juan Diego, maybe I come to you and switch focus a little bit. Could you tell us, you're a geologist, for our audience, what do geologists do, and what kind of career opportunities are there for geologists, and what do you do specifically in your role?
Okay, so as a teacher, I teach geochemistry, mineralogy, environmental science. I teach topics which are connected to many areas of research today. In particular, for example, CO2 sequestration, environmental problems which are related to contamination of microplastics, many of these topics, okay? And in particular, in terms of research, I am a quite active researcher, and I'm trying to understand how specific elements move in fresh water, in seawater, in the environment, let's say, and how we can use them for our technology. I mean, to benefit our technology, and how we can decontaminate them from polluted waters and so on. Okay, so. In terms of advice to students, I will say that, okay, if you want to study natural science, I mean, botany, zoology, environmental science, from a philosophical point of view, I think this is a very interesting area of research, because we are part of something bigger that we call nature, which we don't fully understand. So we need to understand much better how nature works from many points of view, okay, from the atomic to the planetary scale. Okay, because nature can teach us many solutions to our current environmental problems. I mean, problems that are moving from climate change to contamination of microplastics to pandemics to industrial pollution, many of these things. Okay, so if we want our future generations to have a good quality of life in the next decades and centuries, I think it is essential to deal with these environmental problems and to use science and knowledge to tackle them. Okay. From the point of view of jobs, no, I'd like to share with you, if you don't mind, one little slide in which I'm going to try to share the screen, if you don't mind. So these are jobs that, for example, our graduates in environmental science and also in biodiversity and conservation get. So for example, some of them go to the PhD stream. They want to do a PhD to learn more, to do research. So no, they follow this line, and we have very successful examples in Trinity. Okay, and there are jobs like people working as GIS technical assistants, environmental consultants, ecologists. No, we have people who are working in areas of field research. No, in as marine scientists, advisors. They work in ecology research topics. No, they have, for example, very good competence. Very good competence as a science communicator. I know a couple of very good science communicator people. I even know some people in Trinity who have been dealing with the problem with, I mean, what we call usually fake news. Okay, what I mean is that news which are giving us information which is not realistic from the scientific or even from the political point of view. Okay, how to demonstrate that where the real sources of information which can be useful for us. No, we have people who have been working also as a research assistant or associate, part of the PhD students that I have go in this direction. Okay, and we have many environmental consultants. We have marine biologists. No, we have, I mean, many people even working with specific instruments. Some of them become specialized in this or that techniques, and they focus their work on that. For example, one of my PhD students, my former PhD students, became an expert in electron microscopy, and now she has a very important role in one company in the UK named Oxford Instruments, which is the company that manufactures electron microscopes. Okay? Or, for example, there are people who are science writers who are working on water quality, on environment. They are working as environmental analysts. Okay, and I mean, this is just an example. I can provide this list to all of you if you want to see some examples of jobs which our graduate and master people get. Okay, and there is a big plethora of this. No, and for those of you who want to do research, I can tell you that you drive your research. You slowly create your line. I mean, you create what you want to become. Okay, and I would recommend you to follow any lines you like. Okay, I will recommend you to follow your instinct and think about what you want to be and try to fight for that direction. Okay.
I think one of the things that may be a little surprising, or maybe not, to many of the attendees here is that typically when you're coming from the high school system, your experience and your environment tends to be relatively homogeneous. So most of the people in school are like you, and most of the teachers, even if they don't seem like you, were like you in the recent past and are probably living in the area and come from a similar background. And universities, and Trinity in particular, is known as one of the most internationalized universities in the world in terms of its student and faculty composition. So you've probably already got a sense of that, listening and indeed looking probably at me versus listening and looking at Juan Diego. You can tell we didn't grow up beside each other, but we interact with each other, and those differences in background, both technical but also cultural, create a very rich environment and bring new perspectives and new ways of thinking. And Daniele, maybe could we bring you in at this point and just maybe briefly say a little bit about your background and how you came to Trinity, and then I'd like to talk a little bit about Easy Hydro.
Sure. Yes, so I'm originally from Italy. I did my my undergrad, my bachelor's in Italy in engineering, and then I moved for my master's to Poland and then to Portugal, where I got the degree, and then eventually came to Ireland for a PhD. And so I arrived in 2016 at Trinity, and I have to say that it was a really great experience. I was part of a team in which we were researching different renewable energy technologies, all connected with water, essentially water and energy, different streams of technology. It was a very international team from Spain, Belgium, Serbia, it was Brazil. It was a lot of different nationalities, it was a really nice experience, not just as in terms of research outcomes, but also personally in just hanging around the office and chatting with the colleagues.
And maybe just to talk a little bit about Easy Hydro, you mentioned that as a researcher, as a PhD student in that group in civil engineering, you were looking at renewable energy and a lot of aspects surrounded with water. That led, I mean, perhaps not a single straightforward, obvious journey, but it led to where you are now, which is the chief executive of a company called Easy Hydro. So could you tell us, first of all, what Easy Hydro do, and then how did you go from being a PhD student within the university to being chief executive of a company?
Sure. Well, it's quite a small company still, but we are growing to be into a nice SME, hopefully. But it's so what we focus on is designing and supplying and installing basically small-scale hydropower turbines. And here the main challenge was essentially how to make hydropower cost-effective. So that's it's a technology that has been around for a long year. It's the longest lived renewable energy technology. Essentially, the hydropower turbines design has been pretty much remained the same in the last 150 years. But respect to, for instance, solar PV or wind power, there hasn't been much of a cost reduction over the last few decades. And therefore, what basically the technology consists of cost-effective and small-scale water turbines. And yes, so it was a technology that's been developed over several years of research within two different projects. One of which I was involved in during my PhD. So I have to say, yeah, it's very exciting to carry out a research spanning from the initial desk studies to lab experiences to prototyping and testing out different trial units with industrial partners, and which was basically, this was the path of the PhD I did in Trinity. And then at the end of it, with some of the colleagues, some of the industrial partners, and some of the professors involved, we decided, we saw that actually what had been developed had an actual potential on the market. So also thanks to the assistance we got from Trinity's technology transfer and all the various advice we got on the way, we decided after a little while to incorporate Easy Hydro as a company.
And if I could, I'll try if I can to maybe explain a little bit about the technology to our audience, and please correct me if I get this wrong, but in a really sort of simplified way, I suppose there's we've all probably heard of a pump, right? And if you want to have a pump to pump water, you can think of a pump as or a certain type of a pump, at least, as a device where you put in electricity you make something turn, and the turning part pushes the water through. There's lots of applications where people need pumps, in your house, in your washing machine, in water distribution networks, in factories, etc. So pumps are a very widely used technology. And on the other hand, you have people who make electricity, and traditionally that was very large companies that were part of the government in most countries, and now it's much more common and more distributed, and people make electricity at smaller scale in lots of ways. And one of the ways of making electricity using water is when you have flowing water, is to put flowing water into a machine to turn something, and to use that thing that's turning to actually make electricity. So if that sounds similar to a pump, it's because it is. It's basically a pump working in reverse. And I guess Easy Hydro's vision and brainwave essentially was to connect the two of those, right? That there's a lot more pumps available more cheaply than generators. So if you run a pump in the opposite direction, you actually have a small generator, and it mightn't be an optimal generator, but it'll be a very cheap solution for creating some electricity. Is that a fair summary?
Yeah, that's a brilliant description. Yeah, I was taking notes. Nice.
Thank you. You're very
exactly.
kind.
So yeah. I mean, yeah, exactly. So yeah, you summarized it perfectly. So traditionally, you have the generators of the hydropower turbines that are expensive, custom-made, although very efficient type of devices. And on the other hand, you have water pumps, which is probably the most used piece of machinery worldwide, most likely. And just to give you, I remember some statistics that like 4 or 5% of all electricity worldwide is consumed by water pumps. So it's, yeah, they are mass manufactured, they are really widely available and quite inexpensive. And so what we achieved was, basically understanding how they behave in reverse as a generation devices, and then marketing them to different companies that may need our hydropower generation source.
Great. And I guess what it illustrates in many respects is the nature of modern engineering. I mean, there's a civil engineering component to that, there's an energy component to that, there's a mechanical component to that, but there's also an imagination, and I wonder, could we do this, or I wonder, why don't people do that? And seeing the world not just as how it is, but how it might be. And that's in essence the engineering philosophy. Shirish, I wonder, could I bring you in at this point, and
yes,
maybe just to remind the audience, Shirish is a fourth-year student in mechanical engineering. Could you tell us a little bit about your background in terms of what brought you to Trinity, and why mechanical engineering, and what is it about mechanical engineering that you like? At least I hope you like.
Thank you so much. So I came to Trinity due to my previous experiences with Irish people. And I've had very profound and positive experiences with my dad's colleagues. So they'll like send him over. He got into Trinity. It's one of the best schools out there. So I came here, and then in regards to engineering as such, there's a vast opportunities in terms of mechanical, civil. So I'll be talking just my mechanical experience here, but then keep in mind that you'll go through all the fields of engineering during your course at Trinity. So you'll be familiarized with the computer science part of it. You'll be using a lot of MATLAB. So Trinity is primarily, like Professor said, is a research institute. So you get high quality trained professors that put you onto projects, and so your normal assignments would be building a CAD model, or fixing an issue that is very relevant to the industry right now. So we're currently working on acoustic silencer using metamaterials. So it's very interesting topics that Trinity professors choose for students to tackle and build their skills. So you'll have a ton of projects in your field as assignments, which is very interesting, and it builds you. It makes you use a lot of different fields. So I use Python, for example, for data extraction in a mechanical engineering field. So it's very intertwined in that sense, and it gives you a better perspective on engineering as such. Another reason why Trinity engineering is beneficial that I thought was its exposure to the industry. So they rather than just the technical part of it, they teach you the industry relevant management in your final year, especially for me. So they make you really, as an industry like relevant leader once you come out of Trinity. So it's very career oriented as well in that sense. So I did an internship with a company called Leo Lynch. So they're primarily a pharmaceutical manufacturing. So they fabricate the plants for pharmaceuticals. So I interned there, and the technical director was from Trinity. So it puts you in places, I'd say. So Trinity is definitely has a good alumni status in that sense, that help you develop as a person, as an engineer, as a person in STEM throughout your career. So apart from just the academics, there's plenty of clubs and student activities that go along in Trinity. So one of my closest friends and my batchmate is the head of design in Formula Trinity, and my TA is the head of Formula Trinity. So Trinity has its own Formula team, which incorporates the mechanical and the computer science aspects of it. So your drivetrain, your powertrain, everything. And then there's also the finance part of it that's done by the business side of Trinity. So there's a lot of intercollaboration in Trinity, which I've really found beneficial. Just hanging out with all the people and hearing their perspectives and experiences. Also, you'll like myself as an international student, you will be traveling from around the world, being so far away from your families, but you will make close friends from different parts of the world. So definitely indulge in their cultures, embrace your cultures with them. So I not a primary sushi fan, but then my closest friend who's Japanese, he put me on one of the best sushi. Now I'm addicted to sushi. So, you'll find different things in Trinity, the diverse cultures that go along with it, that'll definitely help you and put perspective, especially in STEM, where everything is intertwined and interconnected these days. Yeah, and be cost effective. Definitely, Dublin's an expensive city, so as a student, definitely be cost effective. I'm just giving you certain parts of my experiences that will be beneficial to you. Cooking is definitely the way to go, and and also enjoy yourself, I'd say. Trinity and Dublin is a place where you can embrace different cultures and embrace the Irish culture as well. I love the going to a pub after a couple of assignments, and I know a lot of people are under 18, but I'm above 18. So just going off, letting loose after a couple stressful assignments, so definitely Trinity as a whole give you the complete package in terms of student experience, and builds you as a industry STEM leader in your careers, in your different careers. Hope that answers the.
Yeah, more than answered it. Thank you.
Thank you.
Comprehensive. And last but not least, in terms of our panelists, Hazel, I'd like to bring you in, and maybe you could tell us, you're a second year student in computer science and geography. So maybe you tell us a little bit about what led you to Trinity and to computer science and geography.
Yeah, definitely. So I'm from the Bay Area, California. So I grew up in an environment that was very much, technology based, and everybody around me, my parents were computer scientists. And, all my course mates in high school, we were all taking the same computer science classes. So I definitely could have stayed in California and gotten a really good computer science education. But I kind of knew that's not what I wanted. I wanted to come to Trinity. There are a couple of reasons for that. One of them was I definitely wanted a very international experience. I wanted to come abroad and experience a different culture, and I've gotten to do that, and it's been very great. Another factor, I guess, that's quite important is Trinity does have a really good computer science course, and Dublin as well is a very good city, I think, to learn computer science. There are a lot of industries here, so job opportunities in the future. But I knew, I guess, that I wasn't the type of person who was just going to be studying pure computer science. I wanted something else with that. And I've always been very interested in geography and environmental science and the environment at large. And so when I saw that Trinity had this particular course offering, I kind of fell in love with it. Yeah, I really had my heart set on it because I thought it was like a very interesting thing. Not many universities offer computer science and geography. And I've really been able to, and I think even more so as in the future, but to combine the two subjects. And I think it's a very beneficial thing, like with everything, you know, climate change, inequality in terms of geography. And we've really been learning all of that in geography about all the different causes for, you know, geospatial inequality and climate change and environmental effects and damages. And I think as a computer scientist, I'll really be able to hopefully, I guess, go into the world and come up with solutions for that and use my background in geography to and apply that to computer science. So, yeah.
Great, thanks, Hazel. And the Bay Area is one I know well. I've been there many times, indeed lived there for a little bit. So I guess picking up on Sherish's point, Dublin probably doesn't seem quite so expensive when you've come from the Bay Area, and maybe smaller and more intimate as well. I think we're approaching the point at which we can go to the question and answers at this point. So again, I'd encourage anybody in the audience who has a question just to type it in there, and we'll discuss that. But maybe I'll just throw a question to our panelists, and I guess I'm thinking mainly of Juan Diego and Glenn here, but anybody else, maybe feel free to pitch in if you have something you'd like to say, or indeed just a question a little bit further. And that is the Capstone Project. Can you talk about what is a Capstone Project and why is it an important part of the student experience in Trinity?
So, I mean, in simple ways, no, okay. Any student who is in her fourth year will do a capstone project, which, let's say, it is in average 6 months. Okay, and this is the first approach to research. What I mean is that what you learn, in fact, is that there is no answer to research. I mean, research is the answer to better understand the question very often, right? So you go to the laboratory, you do field work, you do computer simulations, so you see. I'm going to call this the real world problems, okay? So we are trying to understand why some processes happen or how we can explain the way that some aspect of nature works, no? And what usually happens is that what you originally think does not fit with reality, okay? So we expect nature to behave in one particular way, but it doesn't. So what you do is, for a small amount of time, for a not very long amount of time compared to a PhD, for example, you do research, going to the field work, doing field work, lab work, doing I don't know, computer simulations, anything you want to imagine. You have to condense your research into a document in which you explain what is the background and the information that I mean, why you are doing that, what is the big picture of this, what kind of analysis or techniques or methods you have used, and then what are the results from this kind of research, and what is the conclusion taking into account the big picture that we know so far, how this makes some progress, no, in the state of today's knowledge. Okay, I hope this works.
Sure, thanks. Glenn, anything you'd like to add to that?
Yeah, I mean, I think that's a really great summary of like what the purpose of the Capstone project is and what it does for us. So you do it, you know, it's the capstone on your whole degree. You do it at the end of the process, right? Year 4, as Juan Diego says, or year 5 if you choose the 5-year track. And in some ways, like, I see it as being both an opportunity for you to dive deep into something that's of interest to you with the mentorship of an individual academic, because it's a unique project to you, and often the best ones are asking questions that the students themselves are bringing and proposing, rather than taking a project that is just defined for you. But the other is it kind of forms, I suppose, a little bit part of the apprenticeship or the first stage of the apprenticeship of learning how to be a researcher, learning how to be somebody who creates new knowledge, and to ask interesting questions and to work out how to address them. Really, what you're doing is you're spending 6 months diving really deep into something that's of interest to you, something that's maybe unique to you, a question that's not been asked before, and it's a chance to do some meaningful work. And if you're good at it, and if you're lucky with it, maybe a little bit, you can do something really kind of meaningful that will actually appear. You know, it might get published. I've published papers in the academic press and the scientific literature with students who've done these capstone projects, taking kind of things they've created or discovered and writing them up for the community. So it's a real opportunity to kind of put your, you know, set your own path forward and do something that I think, you know, lets you really deepen your knowledge in one area. And it's such an individual thing. You work with one academic on it.
I think even the language and the word is interesting. You know, that capstone, the analogy comes from building, and the idea is that you put blocks together and you build and you create a construction, and the capstone is something that sits on top of that. So when you've built the structure, then the capstone is the thing that makes it complete. And in an educational sense, that's, I suppose, what we try and do with the project, that we give you the building blocks to become whatever it is, a botanist or a computer scientist or a geologist or a biomedical engineer. But the Capstone project provides an opportunity for you to integrate all that learning, but also to do that in a way that expresses yourself. So it's quite a creative and a personal experience, and one that's shared. There is this element of mentoring and apprenticeship where you're working closely with somebody, and it's almost a handing over of the reins. You know, you're a dependent learner, I would say, largely up to that point. You rely on material and instruction and from the professors, but the Capstone project is a transition to being an independent contributor of that particular discipline. So whether that's an engineer or a scientist or whatever. And, you know, on a very practical level, one of the things that our students will find and do find is that when you want to leave the university, whether that's to go to industry or to go to another university, you'll typically engage in an interview process. And the first thing that they will ask you about, and the most detailed part of the interview, will always be about your capstone project. And it's because they trust that, you know, we train you how to solve equations or to do particular types of experiments or whatever is relevant to that discipline. But the Capstone project is a sense to really, is an opportunity to get a real sense from an employer's perspective of how might this person fit into my organization, or what might they be able to do. So it's a really powerful experience. I'm not seeing any questions there that haven't been answered. Maybe Mel, you could draw my attention if there are. So
There are 2 questions in the chat box.
Oh, right. Okay.
There's a Q&A chat box as well there, Kevin.
I see. Sorry, I get that now. Okay, so we've Akshaya from India who got accepted to engineering and wants to specialize in biomedical engineering. So can you do your own undergraduate research as a biomedical engineering student at Trinity? Yes. I mean, you can do that as part of the Capstone project we just talked about. On a smaller scale, there are a number of other modules where there would be some project work. Usually that's in groups, but not always. And in those, you will often have a degree of choice. So you would choose which area you're going to do your particular project or your team's project on. So in a sense, that's research, your own undergraduate research. And there are other opportunities. Typically, a lot of my colleagues will look for students to work with them, and I say with rather than for, with them during the vacation periods, for example, to gain experience. So it is possible to do that, but the main part is really going to be your capstone project. I see we have another question there: the connection between computer science and engineering, and in computer science and geography. I'm not quite sure how to interpret that, but I would say in computer science and engineering, to take that first bit, I mean, in many universities around the world, computer science and engineering will be part of a same bigger group, and I guess in E3 we are that in a way. We have a joint program between computer science and engineering, which is the computer engineering degree as distinct from a computer science degree. And we have lots of collaborations and connections at the research level as well as at the teaching level. So I'm sure Glenn would be able to elaborate if we had a lot more time, but on his teaching, for example, he's working with colleagues from engineering, and they coordinate and deliver teaching together. The other areas between computer science and geography, that's a new program, I guess, and those connections are evolving, but I think Hazel spoke quite eloquently about how, you know, she embraces both of those identities and uses each to feed and stimulate the other. The question about the invitation process at Trinity, where to apply or look for, and I think I'll leave that to Michael to deal with in a few minutes. Then we have a question: are E3 and STEM the same concept? No, STEM is an acronym that refers to science, technology, engineering, and mathematics. I mean, in one sense, I suppose, yes, it covers everything. E3 is a lot more specific. It's focused on climate and sustainability and natural capital, the resources of the world. And it also sees a holistic relationship between all of those. So the educational experience involves exposure to and working with those disciplines, and the research collaborations are deeper. So STEM it doesn't necessarily imply that the disciplines collaborate with each other. So they are distinct concepts. As a researcher, can you still, this is actually again, can you still pursue building something if you do not immediately know how it will benefit the world? Yes, I mean, there are, you know, research is about answering questions. So you pose a research question and you provide the answer to that, and the immediate benefit of that may not be obvious. So, you know, a classic example of that in engineering or technology would be the laser. You know, the laser was invented and it wasn't really quite clear what it would be used for, but now lasers are used in all sorts of everyday fields, from, you know, communication to measurement to manufacturing. So the immediate application of technologies not always, or not just technology, of knowledge. There is value in advancing knowledge for its own sake, and then there's more directly, I suppose, or purposefully trying to bridge a small gap for a specific purpose. But we as researchers do both of those things. What advice would we give for a high schooler who wants to be a civil engineer? I'd say go for it if you like it. I mean, talk to civil engineers, and we heard from Daniele and try to understand a little bit about what they do. You know, we have a strong civil engineering program here. It incorporates civil, structural, and environmental engineering are related, but have distinct focuses or foci. You know, the environmental aspect, if that's of an interest to you, then I think the environmental science and engineering course might be worth considering. If it's other aspects of civil engineering, civil infrastructure, etc., then the general engineering program leading to civil engineering would be good to look at. Is there any research regarding analog technology and its implementations in the future? It's not one a question I'm probably spectacularly qualified to answer, but I would say our colleagues in electronic engineering, there are definitely people doing hardware and analog electronics. So yes, I think is the answer to that. I'm interested in applying to computer science. I'm currently a 12th grade in Indonesia. I do have SAT and TEFL very qualified. So I think again I'll pass that one to Michael. I'll take one more and then hand over to Michael. The opportunities to study abroad in the third year, specifically, how many opportunities are given each year? I hope I'm not getting this wrong, but Melanie or Derbala might be able to interact if I am. At least in computer science and in engineering, the opportunities to travel are generally in fourth year. And typically they are either a semester abroad, a year abroad, or at least in engineering, we have a possibility called Unitech, which involves a year abroad, but half of which is spent in industry. Maybe it's different in natural science, where the year abroad is in third year. And I don't know if Juan Diego, you had anything to add. If you don't, that's okay.
Well, I mean, the only thing I will add is that, I mean, some of our students have done Erasmus during the third year, and we have some agreements now between Trinity and some other universities. Usually that happens for half a semester, okay? And they have very good experience. I mean, they get very good experience, and when they come back, they say that they enjoy, so that always adds, it never subtracts, okay?
That's half a year, I assume, is it once?
Yeah.
Yeah.
Yes.
Okay, I'm keeping an eye on the time here, and we did promise to finish by 11, so a minute or two later than promised. Michael, maybe I could hand over to you to bring us to a close, and thank you all for the questions.
Thank you, Kevin. So my name is Michael Inyaro, E3 Recruitment and Student Officer. I just want to say thank you all to our panelists, Professor Kelly, Dr. Strong, Dr. Navarro, Dr. Rodriguez-Blanco, Hazel, and Shirish. Really appreciate your time. Thank you very much. Unfortunately, we don't have much time left, so I'm just going to give a quick recap of our E3 undergraduate programs for those of you who came late. I just want to talk about our E3 undergraduate programs. So we have 3 schools: the Schools of Computer Science and Statistics, the School of Engineering, and the School of Natural Sciences. And within these 3 schools, we have a host of multidisciplinary programs within the School of Computer Science, Engineering, and Natural Science. Thank you, Mel. So as you can see there, we have a host of multidisciplinary programs, like I said. So for example, if you're interested in learning deeply about software development, machine learning, artificial intelligence, or any programming language you could think of, then we have the right programs for you in the School of Computer Science and Statistics over there. And then I know we probably have a few SpaceX and then Tesla fans within our midst here. So if you're interested in building rocket ships, you want to work on complex designs that help solve world problems and bring solutions to world problems, then we have a host of engineering programs for you there. And then within our School of Natural Sciences, we have within our School of Natural Sciences, we have the Biological and Biomedical Sciences program. And essentially, that gives you a vast range of knowledge and research and teachings from fields of zoology all the way through to biochemistry. And we also have the Geography and Geoscience program there. And fundamentally, it's about the teachings of Earth or the planet and the inhabitants in it. I know we have different people from all over the world here, so we have different scholarship options for students from around the world. We have the Global Excellence and E3 Scholarship. This is strictly for non-EU students. We also have the Foundation Scholarship for Irish, EU, and non-EU students. As you can see, there's flexibility amongst them, and the most essential thing is that you do have to have received an offer from Trinity College before you can apply or agree yourself to the scholarships. I see that a lot of us have questions about different programs and interests and how to get into our Trinity program. So we have our one-to-one booking link here. If you can just click on the link there, or you can take it down and you can reach out to myself, my colleagues Mel or Nara, and we'll be in touch and answer any of the questions you have. I just want to say Thank you all for joining our webinar today. It was very informative and very knowledge filled. I hope that all of you have a good weekend. And if you want to reach out and you have more questions, please reach out to us at our email here at the e3.team@tcd.ie. I'll say that again, e3.team@tcd.ie, and we'll respond to any of the inquiries you might have. Thank you very much, everyone. I hope you have a great weekend.